Now let me explain how do we know which one is in the burette? Or in other words, how do we know which one is the standard solution? Is it an acid or a base without doing the experiment? If we know the pH titration curves, we can easily tell what is in the burette. Or in other words, what is the standard solution in the burette. If you look at the plot on the left, the pH is decreasing. That means the standard solution must be an acid, because only acid will decrease the pH during an acid-base titration. If you look at the plot on the right, the pH is rising. Therefore, the standard solution must be a base. The unknown solution must be an acid. Even if we did not do the experiment, if we look at the pH titration curves, we can still know which one is in the burette, or which one is the standard solution. The very last question. From the pH titration curve, can we know whether the unknown acid is a strong acid or a weak acid? The answer is yes. Actually, I already told you this before. Because from the pH titration curve, we can actually get the pKa of the unknown acid. If you know the pKa of the unknown acid, obviously you will know whether it is a strong acid or a weak acid. But I still want to show you 4 different curves with different pKa's. pKa equal to 2, pKa equal to 4, pKa equal to 6, pKa equal to 8. As you can see here, the smaller the pKa, the bigger the pH jump. If we keep increasing the pKa of the weak acid, we will end up without a pH jump. Actually, if the pKa is larger than 8, it will be difficult to do titrations. Another observation from this pH titration curves is, the larger the pKa, the higher the equivalence point pH. So you can also judge whether it is a strong acid or a weak acid by looking at the midpoint pH of this pH titration curve. As we can see here, for pKa equal to 8, the midpoint is here. It is about equal to 10 or 11. But if pKa is equal to 2, the midpoint pH of this pH jump is around, I would say, a little over 8. That's all I want to explain.